Okay, I'm going to work the problems from our assignment 8.2 with the law of sines. There are 10 problems in total. The first ones are more about the skills and the last ones are applications related. So if I run out of space on the actual page, you may see me switching to college paper. Otherwise, I'll also try to bring in the calculator so we can watch that as well. So let's start with number 1. We have a basic triangle with two of the angles known and the third one not known, and one of the sides known. So we have angle, angle, side. We're going to use law of sines to do that. So the first thing I always do is to complete all of the angles. So angle A is going to be 180 minus the other two angles, 80 minus 45. So that is going to equal 55 degrees. So that's 55 degrees. All right, so we can put that there. Now that we know that, we can set up our equations. So we can solve for first A. So let's go sine of A over little a equals sine of $80, so that's b over little b, and that would be sine of 55 over a, which we don't know, equals a sine of 80, so sine of 80 over 4. Okay, so now let's just rewrite this. So it's a equals, so a equals 4 sine 55 over sine of 80. All I've done is multiply things through, multiply this to both sides. So I've got the a in the numerator, cross multiply basically. 4 times sine 55 equals a times sine 80, and then divided both sides by sine 80. So now we just go to our calculator and we go ahead and let it focus, and we will go 4 times trig sine 55, I use the tab to get out of there, divided by trig sine 80, control enter, and I get a is 3.327, and they want it in 2 decimals, so 3.3. B will be, I'm sorry, which one is left? Yeah, so I guess that was, let me rewrite this just to keep it clean. So now we're going to write B is going to equal, let me start over, let me write this as the law of sines first. So sine of B over little b equals, keep the same sign of C over C. So that would be the sine of 45 over b equals sine of 80 over 4. Alright, so then little b equals 4 sine 45 divided by sine of 80. And that, calculator, 4 times equals 2.87. So if you want to take a moment and pause to look at the calculations in the calculator, go right ahead. So that would be 3.33 and 2.87. All right, let's move on. The next one doesn't have a diagram, but it gives you angle A, angle B, and little a. So the first thing I do is find angle C. So C equals 180 minus 70 minus 10 equals 100 degrees. So now I have all 3 angles. I'll just go ahead and write that down. Now let's set up for B. So we have sine B is 10 over little b equals Let's do the A. Sine of A, 70 degrees over 8. Do the same thing we did in the previous problem, and we rewrite it as B equals 8 sine of 10 divided by sine of 70. So that B equals 8 times divided by sine of 70. They're not sine 70. One, 4, 7, 8. So that would actually be 1.48. And let's see. So that's 1.48. And let's do C. I think for C, I'm going to show how I get to this step just once so that we actually understand the real steps. So let's lay it out. So sine of, what is the angle C of 100 over little c equals, we'll keep it sine of 70 over 8. Okay, so how did I get to c equals? So first thing, it's easy to do a cross multiply. So I got 8 sine of 100 equals c sine of 70. So cross multiply the equals. And then I divide both sides by sine of 70. And so I'll do the sine 70 over sine 70. These cancel out, and there I get my c equals 8 sine 100 divided by sine 70. So let's do that. Hopefully that helped. 8 times sine 100 tab divided by sine of 70. And we have c equals 8.38. Okay, do it again. Let's look at this one, make sure we have space. All right, sine of, I'm going to cross this so we don't get confused. All right, so now we have A is 10, B is 10, and little c is 9. So the angle C is 180 minus 10 equals 160 degrees. Now, since we see that these are both 10, we know isosceles triangle, which means if I find A, I will also find B, so I don't have to do the calculation twice. So let's go ahead and write the 160 in here. Set it up. So let's go sine of 10 over A equals sine of 160 over 9. Do the cross multiply. I think I'll put that step and leave it there. 9 sine 10 equals A sine 160. And so 9 sine 10 over sine 160 equals A. 9 times sine 10 tab divided by sine 160, and we're control enter. That didn't work, so let me try that again. So let's see, 9 times sine 10 tab divided by sine of 160, 4.57. And so, since these are both 4.57, and this is going to be isosceles, so that's 4.57 as well. So those are the first 3 problems. I'll check 10 minutes in. It's going to be a long problem time side. All right, so let's look at this. Number 4, can you see it all? 2 sides and an angle are given, and we want to determine the information results in 1 triangle, 2 triangles, or no triangle at all. So let's solve it. So let's say we have B is 4, C is 5, and the angle B is 20. So the first thing we do is we find the first angle C. So these are the 2 things that we know. So sine of B over B equals sine of C over C. fill in what we know. Sine of 20 over 4 equals sine c over 5. All right, so let's find sine of c equals, okay, that's my dog's nose. Get back. Sine of c equals 5 times the sine of 20 over 4. All right, let's look at that, because we're going to do some, let's see what happened here. Let's see. All right, so 5 times sine of 20 divided by 4 equals, I did it again. Let's see, 5 times trig sine 20 divided by 4. One more time. 5 times sine 20 tab divided by 4 equals 0.4275. Now I'm not going to do anything there. I'm going to leave it in all of those decimals, and now I'm going to find the inverse using that as the inverse. So I'm going to go sine inverse of the answer, control negative, equals, so C, I'm going to call it C1 for now, 25.31 degrees. So if C is 25.31, we can find A1 by subtracting everything from 180. 180 minus 20 minus 25.31 equals, so let's see, 180 minus 20 minus 25.31. So A1 equals 134.69 degrees. That right there. All right, so for now, I'm just going to, the best way to do this would be, well, I've got this. Now let's find out, before we move forward, and let's get A1. So let's use this to get A1. And this is where I'm going to run out of space. So let me make some adjustments here. Let me copy this over. Alright, so let's just take this. So what have I gotten so far? And this is number 4, so in case you see it on your recording, you want to scan to it. I have C1 equals 25.31, A1 equals 134.69, and B is consistent throughout, 20 degrees. Alright, so the question is we don't know if there's a C2 involved or just one triangle, so we're going to find that out later. So let's find and complete this by getting, what's missing is A. Alright, so how do we get A? We have the sine of 134.69 divided by A equals the sine of 20 for the B divided by 4. A equals, click 1, A equals 4 sine 134.69 divided by the sine of 20. I still have that in the calculator, so let's see. Third times, back it up, 4 times the answer, back it up, 4 times sine, answer, there we go, tab it over, divided by sine of 20 equals 8.31. Well, 2 decimal places. Okay, so we've got one set of angles, and so the question is do we have a second one? We will have a second one if the following condition is met. So we take 180 minus the angle that we found, which was 25.31 for C, and if that, so first of all let's find out. Is 154. Okay, so if 154 plus 20 is less than 180, that means we have a triangle because we have enough degrees left to have the third angle. So let's see, 180 minus 20 minus 154.69. If this is positive, we have a second angle. So let's go with 180 minus 20 minus 154.69, and we get 5.31. Okay, so let's label these things. So this would be C2 equals, and so that makes this A2 would be what's remaining after you have the first two angles. So that's 5. So now we have an A2. We can go ahead and find A2. I think that's all that's necessary now. So let's go ahead and do the same thing we did, A2. So we have the sine of 5.31 over A equals sine of 20 over 4. In case you missed some of that. So A2 equals 4 sine 5.31 over sine of 20. Four times sine 5.31 tab divided by sine 20, and A2 equals 1.08. So let's fill all of those in. All right, so where are we? We're at number 4. So we are going to, yes, there are two triangles. C1 was 25.31 degrees. That made A1 134.69 degrees because they add up to 180. And A1 was 8.31. And when C2 was the larger, which was C2 was 154.69, A2 was 5.31. Make sure you can see all of that. And A2 was 1.08. Okay. And that is how we find when there are two angles. So I think let's continue on with 5. So we have A is 4, B is 6, and angle A is 60 degrees. So we'll just find, let's lay it out to find the angle for B. So we have the sine of 60 over 4 equals the sine of B over 6. So let's rewrite that. Sine of B equals 6 sine of 60 over 4. Let's see what happens. 6 times and the sine of B equals question mark 1.299. And I put the question mark there because sine of B cannot be greater than 1. So there is, so sine B cannot be, remember, not be greater than 1, because sine goes from -1 to +1 in its cycle. So we have no triangle is produced. So if, as you're solving for the sine of an angle, that number comes out to be greater than 1 or less than -1, then you do not have a triangle. So let's try it again. So now we've had a situation where we had 2 triangles, and now we are at the no triangles, and let's try it again. So here we have A is 7, C is 3, and angle C is 150, so sine 150 over 3 equals sine of A over 7. Sine of A equals 7 sine of 150 divided by 3. Now, just looking at that, what do you think is going to happen? We have, if sine 150 is at most 1, we're going to have something larger than 1 just because 7 over 3 is greater than 1. So sine 150 tab divided by 3, and we have the sine of A being 1.17. Since that doesn't work, so no triangles produced. Alright, so we've had multiple situations, 1, 2, and 0 triangles. Let's move on to number 7, and now we're going to go to the applications. Let me get this out of the way. So we have a picture on this one, which is good. So let's wait till it focuses. This thing gets a little old. All right, so we have the triangle we're interested in is ABC. Angle C is 15. So let me say C equals 15 degrees. A is going to be the supplement of 25, so it is 180 minus 25, which makes it 155. All right, and that makes B the remaining out of 180 minus 25 minus 25, 15. 180 minus 15 minus 155, and we're left with 10 degrees. All right, so we have all 3 angles now, 10 degrees. We have this distance L, which is in my case 1450, and we need to find this side, and this side is opposite C, so we're looking at little c. All right, let's set it up. See if I have enough room here on the side here. Sine of 10 over 1450 equals the sine of 15 over little c. So then let's rewrite that and get as much space as possible. C equals 1450 sine of 15 divided by the sine of 10. So let's look at that on the calculator. Let's see, 1450 times sine of 15 tab divided by sine of 10. And I get C equals 2161.19. Or rounding up to 2 decimal places, so 195 is actually 2.0. So 2161.20. 2. All right, number 8. And now I think we're going to have to switch to some bigger paper. Let's see if I can translate that over. Number 8. All right, we have a plane, and we have X over here, Z up at the plane, and Y over here. And we want to find this height. Is that right? How high is the plane? Yes. All right, so we're going to do 2 steps here. We're going to find the lengths of the sides, and then we're going to use that to find the height in that case, the SOHCAHTOA. So first we'll do law of sines, then we'll do sine equals opposite over hypotenuse. So let's see what we do now. We know that this distance is 1650. We know that angle A is 35 degrees for me. Angle B is 40 degrees. And so what is angle C? C is going to equal 180 minus 35 minus 40 equals 105 degrees. All right, so I have my 3 angles, and I want to pick either of these because if you look at it secondarily, we have a right triangle here. So that could be a right triangle. So this becomes a hypotenuse for a smaller right triangle. So let's find, excuse me, dog. Let's find, this is 40 degrees. This is little b. Okay, we're going to find little b. So I'm going to go with the sine of what was C, so that was 105 over 1650 equals the sine of b, which is 40, over b. Okay, so then let's do b equals 1650 sine 40 over sine 105. Okay, so let's see, 1650 times sine 40 tab divide by sine 105 equals 1098.01. Okay, so what we have is this equals 1098.01. And now let's look at this particular triangle here, X, Z, and we'll just call this something else, M, why not? So we want to notice, so you see that this is a sine, let's see, sine theta equals opposite over hypotenuse. So we're just going to look on this side right now. So then the sine of 35 degrees equals H, which is the opposite, over 1098.01. So the height is going to equal 1098.01 times the sine of 35 degrees. So let's go with the answer times sine 35, control, enter, and I've got the height equals 629.79. So there we have, and then you can see any of that, so let me go over it. So we first found, using the law of sines, B, which was over here, and then using opposite over hypotenuse, we solved for H. The sine of 35 is opposite over hypotenuse, and the H is the opposite, so H equals B times the sine of 35, and that equals 629.79. Alright, so let's look at number 9. I think at this point I'm going to have to start with the paper. Alright, so Pat needs to determine the height of a tree so that it won't fall down onto a nearby fence. So let's look at what she's got. She's got a tree. Alright, and she's got an angle of elevation, which means she measured it there, and that angle was 50. Then we have a second angle. Oh, sorry, let's see, that first angle was 60. And then this angle was 50. And that's B. And then this distance from here to here was 40. Says the position is farther along the path. So I have this triangle. This is angle B. So angle B. Let me take this out of the way. So B equals 50. Let's call this A. So if this is 60 degrees, then what do you think this is? Supplement to 60 is 180 minus 60 equals 120. So let's call that A equals 120 degrees. And then that means C, this narrow one up here, is going to be 180 minus 120 minus 50 equals 10 degrees. So C is 10 degrees. And then we have little c equals 40. So let's look at what I've got here. So B is 50 degrees. Let me draw that picture. So we have something like this. So that's angle B, and that's 50 degrees. That's angle A, and that's 120 degrees. And this is angle C, and that's 10 degrees. And then this distance, little c, is 40. And our goal is to find this height. So we're going to do the same two steps that we did in the previous problem. So let's start with sine of 10 over 40 equals, and we want to get, which one is the best thing to get? I want to get this side here. So I'm going to get sine of 50 over, we said 50 was B, so B. So we have B equals 40 sine of 50 over sine of 10. Alright, so 40 times sine of 50, tab it over, divided by sine of 10 equals this. So 176.46. Alright, so this length here was 176, so little b equals 176.46. Okay, so we know, let's see, we know this angle, we want opposite over hypotenuse. So, and let's see, this angle going back again was 60, because this is 120. So now we're going to look at the sine of 60 degrees equals opposite over hypotenuse equals h over b, 176.46. So 176.46 sine of 60 equals h. Okay, so let's go with the answer times sine 60, and h equals 152.8 2 feet. Okay, so let's see if we've got all of that there. Make sure it's clear. We first used this triangle, so we needed to use the supplement of the original 60 degrees to get the inside angle A of 120. And then we have sine of 10, so we could find that sine here, or the angle here is 10. So we use the law of 10 over sine of 10 over 40 equals sine of 50 over B. We were able to find B, which became the hypotenuse for our right triangle. And then we had to go back to the original angle so that that's part of the right triangle. And then we got opposite over hypotenuse is H over B, and the angle was 60, and so we ended up with a height of 152.8. All right, so one more. Excuse me. Shh, you need to move. No. Come here. What's your problem? Let's go. Go. Take it. All right, last problem. That didn't work too well. I have a dog who wants attention. Stop it. Okay, let's see if I can get through this problem. All right, I think we have enough space here. All right, we have a Coast Guard Station Able, and that is going to be, let's draw the picture. So Able is, let's put Able right here. I'll call it A. And then B is north of it, 160 miles. So A is 160 miles due south of north. So let's just put a little in here like we were on a map. All right, so then a ship sends an SOS, and it is going to be received by both stations. And the call to A, Able, indicates it's north 55 degrees east. So what we said in bearings, we'll start with the north, and the angle from north in the easterly direction is 55 degrees. So it's someplace out here. And in B, from B, it was south 60 degrees east. So again, someplace out here. So it's right here where those two angles intersect. And now we need to find out the distance between from the ship to Able and to Baker. So we now find what angle C is first. So 180 minus 60 minus 55. And that's going to be 65 degrees. Okay, so we have our three angles and we have one side. So let's look at the distance from A to C. So we want to have little b, and this would be little a. All right, so let's do sine of b is 60 over b equals sine of c, 65 over 160. All right, b equals 160 sine 60 over sine 65. (160) times sine of 60 tab divided by sine of 65. So B is 152.89. What are we measuring it in? Miles away. Now let's find, so that means that this is the distance from A, actually. So this is 152.89. Now let's do the other one, which is little a. A equals, or should I write the whole thing out? Sine 55 over A equals sine 65 over 160. A equals 160 sine of 55 over sine of 65. All right, so how much did we miss by running off of the screen? And let's calculate A. 160 times sine 55 divided by sine 65. And A equals 144.61. All right, so the distance from Baker is 144.61. All right, so it's closer to Baker than it is to Able. And so the last question is, if a helicopter is capable of flying 200 miles an hour is sent from the nearest station, which would be Baker, how long will it take to reach it? So we have 144.61 miles, and we're trialing at 1 hour per 200 miles. So we have 144.61 divided by 200, and that equals 0.723. But that's not in minutes, that's in tenths of an hour. So now let's multiply that by 3 times 60 minutes per hour, and we will get times 60. I did miss the 6. Let's see, clear. 0.723 times 60. 43.38 minutes. Okay, I hope that you can use this. It's a long assignment, but you can skip to the problems where you want to look at them.